Today's topic will be data high availability with TiDB. And first of all, thanks a ton for coming on a weekend, spending your time with us. Without further delays, let's get started. Okay. So this is a little about me. I'm interested in open source technologies, and I'm the co-founder of Mydbops, PingCap certified associate, AWS certified database specialty, and further. Just So this is a 1,000-foot overview of what we do at MyDBOps with the 7 years of expertise, having 300 plus customers around the globe and serving around 3,000 plus servers, maintaining the uptime of them and performance. We are also an ISO PCI certified company. We predominantly worked on technologies such as MySQL, Mongo, and Postgres. And also we are a TiDB partner, official partner for the consultation. Okay. So these are the MyDBOps services, what we provide to a customer, consulting services and managed services. Consulting services more of a project-oriented one. Managed services is 24/7 TBA team works to maintain uptime and optimization of your service. And these are the technologies supported: MySQL, Mongo, Postgres, JDB, and Cassandra. Okay. So this is our today's agenda. So first we'll see about what is TiDB and what does it brings to the table. And we'll discuss a small thing about the architecture. This is not about architecture. This is mainly dependent upon the high availability of data. So we'll discuss more on the high availability part. And finally, we'll discuss about the latest labels, that is the placement of the data. Okay. Without further delays, so what is TiDB? So TiDB is an open source distributed SQL database by PingCap. PingCap is a company that develops this TiDB and maintains them. So Ti stands for titanium. So you know about the titanium metal, which is very versatile. So that is the abbreviation for TiDB. This TiDB is scalable in both ways. You can scale your TiDB instances both horizontally and vertically. So horizontally, it supports on-the-fly sharding by segregating your data into ranges and stuffs. And it is an HTAP database. They say it as a HTAP because it supports both transactional as well as an analytical workload. So it is directly wire compatible with MySQL 5.7. And coming back to the recent version of TiDB 7.4, the MySQL 8 features like uh, MySQL 5.7 is end of life by October 23. If you are still using 5.7, it's high time that you upgrade your servers to the 8.0. And TiDB is actually coping up with the 8.0 features. They have integrated all their new features such as Windows function, CTEs, everything with the recent release of TiDB 7.4, which was released on October 12. And this TiDB is high available by default. Okay, we'll discuss more on this high availability in the coming slide, and also fault tolerance. So this is the architecture. You can see in the architecture, everything is loosely coupled. So everything can be scaled individually with respect to the nodes. For example, this TiDB is your SQL layer that handles the connections and passing the queries that you send. TiKV is your transactional storage. TiFlash is your analytical storage, and PD, which sits on top of this TiDB and TiKV, is a cluster manager, or you can say it as an orchestrator. Okay, PD is nothing but a placement driver. Okay, so in one word, these are the functionalities of each module. TiDB, the SQL layer, as we discussed. TiKV is your storage layer, which is based upon RocksDB. Placement driver is the orchestrator. That means it orchestrates all the activities of the cluster and maintenance of the cluster. TiFlash is your analytical storage. This is built on top of ClickHouse, okay, to provide the analytical features, aggregation, pipelines, etc. So from here, we will discuss about the data and its high availability. So first, TiKV is your online OLTP storage. That is, it is stateful, and this is system storage with RocksDB. The underlying storage node uses a RocksDB, which is based upon the LSM tree. So this TiKV supports transaction as well as a distributed support. Means it has the ACID compliance and it is compatible with MySQL. So whatever the syntax you do with the MySQL for the insert update works with the TiKV also. And this is strongly consistent. As I said, data is highly available by default with respect to the TiDB. That is, TAKV minimalistically need 3 nodes to get started. Okay. So TiKV, right? The internal data structure they use for maintaining the high availability is a Raft. So Raft is a famous algorithm in the open source world. So Raft is a consensus algorithm which is used to replicate the data as well as to maintain high availability of the data among the nodes. Okay. So what is the abbreviation of Raft? Raft stands for reliable, replicated, redundant, and fault tolerant. This is the abbreviation for Raft. So Raft forms a group. So as you can see, 3 Raft. So Raft forms a group which has a leader and a follower. The leader role of this Raft handles the read-write operation with respect to the Raft group, and also the replication, also maintains a replication. Followers participate in the election, and also you can read the data from this followers. Okay. Now let's see about how this Raft get integrated with the TiDB. In TiDB, the data is initially, whenever you insert the data, right, the data is segregated as shards. Okay, that smaller piece of data is called regions. So in definition, region is the smallest unit for data replication with TiDB. Each region, for example, each region is replicated 3 times among the TiKV nodes. All the available, as I said, TiK will be 3 nodes. The region will be the smallest unit of replication. This will be replicated thrice. They form a Raft group. These replicas form a Raft group. This region will have that is a leader and its followers. Okay, and the default size of the region is 96 MB, which is immutable. You cannot change the region size. Whenever the region size exceeds beyond 96 MB, a region split happens. And when the region comes below like 20 MB, the region merge happens. Okay, this is how the data is being managed with TAKV. Okay. So as I said, you can see here a Raft group. As I said, a region forms a Raft group. With multiple regions, they form a multi-Raft design. So this is how the data is being organized within the TAKV. You can see multiple TAKV instance. In the diagram, you can see 4 TAKV instance. Within the TAKV instance, each region will have a leader and its followers. They form a multi-Raft design. Okay, so the high availability of data is maintained at a region level, not at the node level. It is at the region level. That is your 96 MB data. Okay. So now let's see about the replication, how it works with the region. So as we said, in a Raft group, leader replicates a log as well as log information to the followers. The log is nothing but the data writes which happens. It's first being written to the log storage. From the log storage, it is replicated to the followers, and the followers acknowledge back on writing this log to its own log storage. That is when the data is being synced. That means you get a commit back to the application. Okay, so first is written to the log storage. From the log storage is written to the rocksdb kv internally. Okay, and as I said, TiFlash also syncs from this same log which is being used for the TiKV, but it uses an algorithm called Raft learner algorithm. That means this learner algorithm cannot participate in the election, and they take only the log information, write it to their own storage. Even if there is a failure with respect to the TiFlash, the TiKV instance or the TiDB instance will continue to run. Okay, so this is the replication process. The replication process happens broadly in 5 phases. That is propose, append, replicate, commit, and apply. So these are the main process. The propose is when a reader receives the write request. Okay, so that is a propose, and the leader writes it to its own Raft log. Okay, and when the Raft log, it from the Raft log, it is written to its Raft engine, which is a specialized engine to store this Raft log and makes it durable. And then it replicates this particular log among its followers. And the next append happens at the follower side. The follower will accept the writes and write it locally to their Raft engine and acknowledge back to the leader that we have received this particular log write, or the log write is durable. And then they apply to their own rocksdb. From the Raft engine, they apply to the TiKV rocks DB. So that is when a transaction become completely durable. Even if there is a failure after writing to the Raft log, right, the data will be recovered from the Raft log. That is how they maintain the durability. Okay, so this is a pictorial representation of what we discussed right now. So each region will have a leader, so which is represented in an oval format, and the followers in a rectangular format. You can see they form a Raft group. They begin the log replication from the leader to its follower and also to the type flash, which uses the Raft learner algorithm. Okay. So now we have discussed about the replication and how they get the data synced between the multiple nodes. Now let's see about election scenarios. So for example, when there is a failure with respect to the nodes, how it is being handled. Okay. And before that, Raft always ensure to have a single node for a region. Okay. So for example, what are the election scenarios when the election can begin? For example, when there is a heartbeat failures. Before explaining the heartbeat failure, I'll say about leader will send frequently heartbeats to its followers to check its health status and those things, and they will acknowledge back. So this is how they maintain a relationship between the leader and the followers. If there is a heartbeat failure, if there is no message of heartbeat from the master, the followers think that the master is no more available, and they start an election. So this is one of the election scenarios. And also, whenever, as I said, when the node size or the region size exceeds beyond the limit, that is 120 MB, the node split happens. A new region will be created. When there is a new region being created, uh, um, all the particular new region will start an election to elect its new leader. So that is also one scenario for election. And also, when there is a node restart for a maintenance, for example, you have three TiKV nodes. When you restart a node for a node maintenance or a OS patch, the leader role which is associated with this particular TiKV will be shifted to the other available TiKV nodes. So that is also induces an election for the leader role switch. And also, when and also, what is election timeout? This election timeout is a special case wherein when there is a consensus happens and no unanimous leader is found, TiDB itself sets a random election timeout to induce multiple elections until an unanimous leader is found. So these are the election scenarios. Now let's see about the election process. Okay. So Raft, that means each region will have a leader, as we discussed multiple times. The leader will maintain heartbeats to its followers, and also the leader will maintain a term. So the term is nothing but a period. It is period, but there is no defined time for the period. Whenever the the candidate or the lead the node or the region which has the highest term will be the next leader. That means it has higher priority to become the leader. So as we said, leader emits the heartbeats to its followers. When, for example, you consider a scenario when a heartbeat fails or a node crashes, so what the followers does is they induces an election, they start an election. So first, the followers change their role from followers to candidate and increment their term. Each region will have a term, so they increment the term, and they first vote to themselves and then send a voting request to the available followers along with the term value, means whatever the term value they have incremented, right? So they will send it on majority. When receiving a majority of acknowledgement back from the followers, this node will become the leader and send back the immediately. Once it becomes the leader, it send back the heartbeat and its term value to the followers, to its followers. Okay. So this is just a pictorial representation of what we discussed as the election process. For example, TiKV node 2 has a region 2 as a leader. In there is a crash, that means this node is not available to emit the heartbeat. TiKV node 3, the region, starts an election and it increments the term from 2 to 3. This is the first step, and it becomes a candidate and votes for itself and send a voting request to the TiKV node 1 region in the TiKV node 1. And once it receives back the acknowledgement from the TiKV node 1, it promotes itself as a leader and start accepting the rights. Okay. So now we discussed about orchestrator, right? That's the placement driver. So that should also be highly available. So the placement driver by default is highly available. Minimalistically, like TiKV, a placement driver also needs a odd number of nodes. That is minimum 3, 5, and goes on. Okay. This PD cluster forms a etcd cluster with a Raft to provide strong consistency of data. So PD maintains the metadata as well as the TSO allocations. So that metadata information is handled by this. So this will be highly available for the cluster, even if there is a failure with respect to the particular leader node of the placement driver. Okay. And one more information that PD maintains is the labels. We'll discuss these labels in detail. Okay. So this is a particular setup of TiDB with respect to different data centers and racks. So I'll just pause the video, or I'll pause for a second, just have a close look at the video, or sorry, close look at the image and find a problem statement here. Okay, I'll just explain. So did you find the problem statement here? The problem statement here is, so we have three data centers, DC1, DC2, and DC3. And within the DCs, we have two racks for per data center, and regions are segregated or distributed among this TiKV nodes with the specific racks. For example, when there is a DC failure, for example, DC2 fails, the region 1 data will become completely unavailable for use. Okay, so this is a problem statement here. Okay. Not even DC, when there's a even when there's a rack 4 failure, right, there will be complete outage of the region 1 data. So data will not be available for the end user. Okay, so how to overcome this situation? By default, TiDB does not know your DC, rack, or the host level or zone, region level segregation, what you have with your public cloud providers. Okay, so to overcome this problem, we have a concept for labels. Okay, so in Cassandra, they call it as a snitch, wherein you can define your DC, racks, and nodes. Similar way in TiDB, we have the labels. So the label is a way to tell the TiDB cluster to place your data or the regions according to the DC, rack, and node concept. Okay, by default, TiDB places the data randomly among the different TiKV nodes for load balancing. Okay, so for this is a example of labels. This label is maintained by the PD cluster because PD is the orchestrator that defines where the data resides onto the cluster. So you can see the location labels. You can define your own labels with respect to zone, DC, and rack. Okay, and you can give the isolation level configuration. What is the isolation level you have to use, whether it's a zone level isolation or a DC level, rack level, whatever you need. And this is a particular example wherein I have 3 TiKV servers. I define the labels for them, and the data will be placed according to this label. Okay, so this is a detailed architecture. First, I showed you a simple architecture. This is a detailed architecture with respect to the regions and the segregation and the Raft group. Okay. So these are some of the simple or major uses of TiDB where it being used in the production. So recently, Delivery also gave a talk on the CTO talk, how they leverage TiDB for the head step use cases and also for the transactional use cases. There is a huge case study on this. And Flipkart, the biggest e-commerce, use TiDB for scaling their servers and for the big billion days. Payment gateway, BookMyShow. So these are TiDB covers a variety of use cases when it comes for SaaS application, IoT, commerce, logistics, and etc. So there are a lot of customer stories. You can read them in their customer stories. I would like to close this talk with the limitation what it is currently present with respect to the TiDB. As I said in the initial itself, TiDB is coping up with the 8.0 and its features, and it is growing fast. And these limitations will be sorted, or there will be a workaround will be provided by them. I think strongly. These are the current limitations with respect to TiDB. That means stored procedures and functions are not supported since it is in distributed in nature, and also triggers, events, and user-defined functions. And column level privileges and full text index are not supported with respect to TiDB. Keep this in mind when you are evaluating TiDB for production. And also, if there's a stored procedure, we have a lot of workarounds around the stored procedure by using some script or things. Okay. With this, I'll close my talk. Thank you.